G'day, it's Rob Farley here. I'm going to take 5 minutes to talk to you today about data movement. Data movement was a thing in PDW, SQLDW, now in dedicated SQL pool in Azure Synapse Analytics, formerly known as SQLDW. And the concept here is that in that massively parallel processing world, when you have data that's distributed across a whole bunch of compute nodes and you want to do something with that data, you need to be able to make sure that the data is in the right place to be able to do it. If you want to join with some data that's over here, with some data that's over here, that doesn't necessarily work because they're effectively two different computers. So you need to be able to do data movement to bring them together. Now, there's lots of different types of data movement, shuffle, broadcast, all kinds of things like that. The one I want to talk about today is trim movement. Okay? Now, trim movement is where you take data that is replicated, where you've got a full set of the data on every one of those compute nodes, and you want to trim it down, basically like applying a hash function to that data that you've got replicated to figure out which stuff actually now belongs on each compute node. We typically see it in when we've got replicated data and then we want to do a CTAS, a create table as select statement, to create a table with that data, but that new table uses a hash distribution. But we also see it, interestingly enough, in left joins. So that's my topic for today, trim movement in left joins. Let's think about why this is the case. Now, in some scenario where we have 60 odd I'm sure we do, 60 distributions, all effectively separate databases with the data spread all across them, and we want to do a left join between some data that is replicated, where we've got a full set across each one, with that data that's got the hash distribution. Now, I totally get that I ought to zoom in here and concentrate on just a couple. You know what? Let's get rid of that bit. Let's change the zoom. Drop back out again. Let's do this on just 2 distributions. Okay. Now, and I'm going to make like my hash function is really simple. I'm going to have odd numbers going to one side, maybe this one over here, even numbers on this one over here. So over here we've got like numbers 1, not number 2. Number 2 goes over here. Number 3 over here. 4 is over here. 5 is over there, for example. Now, that's all well and good for our hash data. That's probably like a fact table. We've got lots of stuff going on. But suppose we've got a small dimension table that we've decided to replicate across the place, so that typically it doesn't need to move to be able to participate in joins and aggregates and so on. Now, that means that we might have this replicated data, 1, 2, 3, 4, 5, 6 over there, 1, 2, 3, 4, 5, 6, our dimension data here that we want to be able to join to our hash data. So what we want to think about is having a join operation that works entirely on here and a join operation that works entirely on there. Let me get rid of those circles. Now, what our broadcast data means that we've got everything down there, and you would think that to be able to do that join, we have everything that we need. However, there's one piece of information that we don't have, and that's what I want to show you today. Now, yes, we can easily do a join on this data between 1 and 1 and 3 and 3 and 5 and 5 and the 2 and 2 and the 4 and 4, and that's all good. If this was an inner join, no problem. We don't need to do any movement for that. However, we're trying to do a left join. That means that we need to figure out that this 6 here doesn't have any data. We still need to be able to return that with the nulls. So what we do to fix that is instead of just doing our join like on the broadcast data, we first do a trim. We work out that we don't need the 2, the 4, and the 6 there, or the 1 and the 3 or the 5 there, right? And then we can do our join, and it becomes very obvious that our 6 doesn't actually hit anything and should be returned with a null. And there you can see a great reason why we end up seeing this trim movement when we do a left join in an MPP environment. Enjoy the rest of the event. I'll see you next time.